Welcome to Sundar's lecture. And in last lecture, we have seen the super mesh problem, and also we have seen the problem how to solve the problem if we were given with the current source, and we are going to approach the problem with KVL basics, and also we would have applied KCL also, right? So we have seen this. Now in today's class, uh, we are going to see resistors in series and parallel. So resistors in series, first topic we will take resistors in series, right? Before this topic, before entering into this topic, we need to know two basic things. One, let me draw a diagram like this. This is circuit elements. You try to understand. This may be a voltage source or a current source, or it may be a resistor, inductor, capacitor, anything. These are all the circuit elements, and it is like this. You try to understand. It is connected like this, and these three elements. This is element. Let me take this is element 1, element 2, element 3. And if you take, if a current I is flowing through this point, through this branch, and you see these all elements are connected in series, and I will tell you how elements were connected in series and parallel. How can you determine whether the elements are connected in parallel series with resistors? I will tell you. And if you see, if this is I am telling these three are connected in series. If these three elements are connected in series, then current flowing through the element 1, if it is I, then the same current will flow in element number 2 as well as element number 3. So I can write here, this is I, this is also I, and current flowing here also I. So in a series circuit, current flowing in all elements will be equal. That point you have to understand. Fine. Now we will take a circuit and we try to get the equivalent resistance formula, right? So I am taking a circuit, and we have taken a circuit. This is our circuit right now. You see a voltage source is connected across 3 resistors, and all these 3 resistors are connected in series, right? Now I can apply KVL, right? I can apply KVL. The current flowing in this loop, there is only one loop. You can see that this is only one loop, and the current flowing will be, what is that? That is nothing but it is I. So if you apply KVL, what you will get if I apply KVL? So apply KVL. So if you apply KVL, what you will get? So here you see from minus to plus I am going, and in all the resistors the current direction is same. So I will write very fastly now. So this will be V minus R into I1, R1 minus R1 I, and you see all the resistors will get the same current as we seen here. All the resistors will get the same current. So what is this one? Minus R2 into I minus R3 into I. That's all, right? No other elements are present here. So we can write this is equal to 0. And we can write this V, which is equal to R1I plus R2I plus R3I. I can write like this, right? So what I will do, I will take this I commonly outside. So what I will get? R1 plus R2 plus R3, right? Right, this is the simplification, and I can write this I, what this V as I into R. That is Ohm's law. That is Ohm's law, right? V is equal to I into R. So what I can do now, this I and this I can be cancelled out. Can be cancelled out. Simple. So what is the final answer? So R, total R, that means R will be equal to R1 plus R2 plus R3, right? Right. So this is the final. So I may write this as R equivalent. That means equivalent resistance of this whole circuit, which is nothing but R1 plus R2 plus R3. Which means if resistors are connected in series, then my equivalent resistance value will be equal to what? R1 plus R2 plus R3. In simple, we can say that we should add all the resistor value if it is connected in series. If you want to find what is the equivalent resistance. So I always use term, I don't use R equivalent because I need to find what is the equivalent resistance for parallel connection. So I always write RS to know that series resistor, it will be R1 plus R2 plus R3, it will goes on till Rn. So how it will be? So if I connect numerous number of resistors in series, then I will get what? Equivalent resistor or resistor connected in series will be this one. This is the resistors in series formula, right? So we will take another circuit now. So now you see I have taken three elements that is parallelly connected to a source. It is connected parallelly, right? Now what it will get? You see, voltage source is connected between these 2 points. Element 1 will get plus and this plus, as well as element 2 is getting the same plus and same minus, as well as element 3 is also getting the same plus and same minus. Since everything is getting the same plus and same minus from a voltage source, then all the elements will get same voltage. Voltage in E1 will be V, in E2 will be also V, in E3 will be also V. There is no difference, right? But what happens to current here? Since this is, you have a node here, current should divide. How? If this current is coming here, total I, then current across this element will be I1, and current across this element will be I2, and current across this element will be I3. And if you take a series circuit, a parallel circuit, voltage in all elements will be same, but current will differ. That's all, right? So we will take a circuit with resistors and we will try to find what is the equivalent resistor. So now you see we have taken a circuit with the three resistors connected parallel to the voltage source. Now what it will be? So this one, what is this? This one will be I1, this one will be I2, and this one will be I3, right? So if you apply KVL, KCL, what you will get here? Let us take this point. I will tell you. Let us take this point as A. So what you do now? Apply KCL at node A, right? If you apply KCL at node A, what you will get? You put equal to symbol. You see I is coming towards this node, So I will put I in the left hand side. And you see I1 is going away from this node, right? So what I have to put? I have to put it in the right hand side. And you see this I2 is also going away, So what I can put here? This is I2, and you see this is I3. I3 is also what? Going away from this node, right? Right. So what I can put? I can put this as I3, right? So total current will be I1 plus I2 plus I3. That's all. So even if you apply KVL here and you get what is the current coming here, everything will be same, and at last you will get what? I is equal to I1 plus I2 plus I3, right? Now what I will do? I am going to substitute the values. What is this total I now? Total I, what is the formula? We know that is V is equal to I into R. We know that. So if I want to write I, that will be V by R. That's all. So this total I can be written as what? Total V divided by total R, right? Which is equal to, what is I1? I1 what is the voltage across this resistor? All the resistor will get what voltage? Same voltage, V. Every resistor is getting the voltage V and resistor value is R1. And if I want to write for I1, it will be V divided by R1, right? Plus, and for I2, for the R2, I am getting current I2, but voltage is same. So this will be V by R2, as well as here you see V by R3. And if you take commonly this V outside, anyhow I will write V commonly you take outside. So this will be R1 1 by R2 plus 1 by R3, right? So now you can cancel these two. And finally, what I can write, this 1 by R, this is nothing but equivalent resistor, total resistor. 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the final answer. And now I have told you already, I don't I will not write R equivalent, right? I don't use R equivalent, right? I always use resistors connected in parallel, RP. That should be equal to what? 1 by R1 plus 1 by R2 plus 1 by R3. And if I have connected numerous number of resistors connected in parallel, then I can write this will be plus 1 by Rn. That's all. So this is the formula we will use forever. This is the formula we will use forever. That's all. So this one you try to understand, and always you keep this like you keep 1 by Rp. Don't convert this into Rp, since you need to take so many LCMs here. It is not at all necessary. You just try to remember the formula. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That we will use. Okay. Now I will tell you one important concept that you try to understand that. So you see, if you take a resistor like this, sorry, we will take like this. So this is R1 and this is R2, right? These two elements are connected to circuits anywhere else. We don't know where it is connected. It is connected somewhere else. You think like that. So now you see, if two resistors are connected like this, which means you see one end, we have two ends of the resistor, right? This one end, this is the second end, and for this resistor R2, this is first end and this is second end. If two resistors were connected only by one end, which means you see R1 is connected with R2 with this end. Other two ends are connected somewhere else. We don't know where it is connected. If you see any connections like this, then obviously these connections are called as series connectors. Series connections. In series connections, only one terminal of the resistor is connected with the other resistors, one terminal, right? That you have to understand, right? Now we take different circuit, which means like this. You see, this is R1. Let me take, this is R1, this is R2, and you see this is the first terminal that is connected to R2. This is the second terminal of R1 that is also connected to R2. And if you see any connections like this, two terminals, both the terminals will be connected in both resistors, which means you see R1 one terminal is connected to R2's one terminal. R1's another one terminal is connected to R2's another one terminal. And if you see anything like this, these types of connections are called parallel connections. And you should know these basics very well. And if you understand this one, then we can easily solve all the resistors problem. Fine. We will cut short the videos. From this video, we will be taking only 15 minutes video, so that it will be engaging, right? So we will see, we will take some problems in the next class with the resistors in series and parallel. Thank you.